Okay, welcome to part 2 of our grasshopper folding pattern video. And in this video we're going to look at mimicking something similar to this paper folded structure that you see here. And we're going to do this through grasshopper. And one of the nice things about this grasshopper definition is we have this one number slider that I've labeled "it does it all" because that's what it does. It does it all. Okay, so let's begin where our last video left off. So we had our 2D folding pattern, and we had this number slider that was controlling what we had called the tick marks, and you can see those moving in and out in the Rhino viewport. So this is going to be our number slider that does it all. So I'm going to take this and move it out to the left hand side and add a scribble. Okay, the other thing that I'm going to do is I'm going to change the range of this number slider so that it doesn't go all the way to the middle like that. I'm going to change the range so that the highest value is only 0.25. So I'm just right clicking on the number slider, going down to values, and under max I'm setting that max value to 0.25 and clicking on the green check mark. Now that number slider's range is from 0 to 0.25. Okay, so the next thing that I want to do is I want to find the center point of this rectangle because I want to be able to raise that center point. And I can show you in this definition that center point being raised. So I want to start by raising that center point. So I first have to find it. So I'm just going to bring out some scribbles to label what we're doing here. So this is find center point. And I think it's worth mentioning what I'm trying to do at the moment is make this one triangular surface. And if I just highlight that, okay, so that's what I'm beginning with. So I'm going to have a base point, I'm going to have a center point, and I'm going to have this left point that create this triangular surface. So that's where we're headed. Okay, to find the center point, I can use an area capsule that can find the centroid of this outer rectangle. So I'm going to double click and type in area and choose area, and it's looking for the geometry to find the area for, and you see the second output creates a centroid or a center point. So this needs to be the area of my original rectangle that I created. So I'll go ahead and plug that in. That finds my center point. The next thing that I want to do is I want to raise this center point up. Okay, and I'm going to do that through a move capsule. So I'm going to double click and bring out my move capsule, and I'm going to plug my centroid into the geometry because that's the point that I'm raising. Now nothing happens yet in Rhino because it needs a direction. Where this says motion, when I hover over it, it says translation vector, so that's the direction that this point should be raised. So I need a z-axis vector, and I'll go ahead and plug that in. So by default, this unit z-vector has a distance of 1, in this case it's 1 inch. So it's raised that point up 1 inch. Now, when I made the paper folded structure at the size that I was working at, 8.5 by 8.5 inches, the highest this point would go would be roughly about 6 inches. So I want to set up some capsules that control that range from 0 to 6 inches. And the other thing that I want to do is I want to be able to use this number slider, which is set from 0 to 0.25. So what I have to do is I have to remap these values so that when this value is 0, it'll stay 0, but when this value is 0.25, it'll be equal to 6. So I'm going to remap those values. Okay, and I can do this through a remap numbers capsule. Okay, so what this capsule is looking for, it's looking for the value to remap, which is going to come from this it does it all number slider, so I can plug that in. And then it's looking for the source range of values, or the source domain of values, and then the target. So we're going to have a source domain that matches this number slider, 0 to 0.25, and then we're going to have a target domain from 0 to 6 inches, which is the full height that I want that point to move. So I'll construct my first domain. So I'm going to double click and type in domain, and there is a construct domain capsule. This will be my source, and this, remember, needs to match this number slider, so from 0 to 0.25. So I can bring down a panel, and I'm just going to put in 0, and I'm going to right click and just name this, or rename it to nothing, not really nothing, but get rid of panel, so I don't have that header at the top. And then I can make this as small as possible, and I'll plug this into my domain start. I can copy and paste this, and my domain end will be 0.25. Okay, so that's my source domain. Now my target domain needs to be from 0 to 6. So I can copy and paste this, change my domain end to 6, and I can plug that in. Now this is what I'm going to use for my values to move this point. So I'll plug in my remapped values into my z vector. Okay, and there you see that point now. It's at 6 inches tall, and we should see that coming out of this map value. So you see it's saying one locally defined value, 6. So as I lower this, it remaps this 0.12, it remaps it to 2.88, and so on. So I have this number slider working. It's controlling my height of the center point from 0 to 6. Okay, so we're going to continue making this triangular surface. The next point of the triangular surface is going to be this point translated in the z direction, or moved up in the z direction. So I have to do something similar. So let's go ahead and organize this a little bit better. So I'm going to go ahead and move these over. I can also group these together, Control G, right click and change the color. Okay, so I need to raise this point up. So again, something very similar. I'm going to need some domains, I'm going to need to remap the values, I'm going to need a move. So I can copy and paste some of these capsules here down below. So I'm going to need the move, the vector, the remapping. I can take these two inputs. Now my 0 to 0.25, my source domain, that's going to stay the same, so I can leave that there. So I'm going to copy and paste this. Okay, so now this domain end for moving that point, I'm going to change that. I'm going to change it to 5 because it's going to be lower than the center point. The center point is up at 6. This will be 1 inch lower. So I'm going to change that to 5. Now, right now we're just seeing that center point lowered down 1 inch. That's because the geometry that we're moving is still the center point. I haven't plugged this point in yet. So I need to go earlier in my definition and find that point. Okay, so that's on one of the vertical lines. So here's my vertical line portion of the definition. I can start to click on these, evaluate curve points, and see which one it is, and it happens to be this first one. So that's the point that I'm going to be moving. Now notice in Grasshopper, when you move, we're using this move capsule. It doesn't just move, it also makes a copy. So I'll go ahead and plug that in. And I'm not using my shift key, so it's going to replace what I had plugged in. And now we see, if I highlight that, now we see this point raised up at 5 inches. I want to add some more scribbles here just to better organize this. So this is my center point. And I can change the size of these scribbles for my headers just to make them a little bit bigger than my other text. So that's my center point. I can also add this to the group. When I have it selected, I can right click over the group and I can choose add to group, and that adds it. And I'm going to select that text, copy and paste it, and drag it down. So of this triangular surface that we're going to be making, this is going to be the lower left point. And I could go ahead and group that together, change its color. Okay, let's look back at the finished definition where I have this surface here. So the next thing that I need is I need this base point here that's sliding back and forth along this line. And if I move the It Does It All number slider, you'll see that. So we have that point sliding. So that's a slider point. So let's go ahead and make that here in this definition. So let's go ahead and make that slider point. So I'm just going to copy and paste this scribble. This will be the slider point. Okay, so this slider point, it's going to slide along a diagonal line from point 2 to the center point. So I don't have that line just yet, so I need to create that line. So I'm going to bring out a line capsule, and the start point is going to be our center point, which is coming out of this area centroid output. That'll be the end point. And then I need to find our point number 2. So I'm going to move this capsule up and plug in our list item number 2, and that creates our diagonal line. Okay, so now I need the actual slider point itself. So to do that, I need to evaluate this line. So I'm going to double click and bring out an evaluate curve capsule and plug that in. So this parameter, which defines the location of this point on the line, I want that to come from my It Does It All number slider. And my it does it all number slider goes from 0 to 0.25. So that would only allow this point to move from here to a quarter way along the line. When I want it to move almost all the way in, and again, let's think of the domain of this line from 0 in the right hand corner to 1 at the center point. So I want this point to move from 0 to about 0.9, not all the way in, just before it closes in. So I can use what I've done above here with our remap numbers. I can select my remap number, my construct domain, and the two inputs for that, and I can copy and paste. And I'm going to change this domain end. This is going to be 0.9. And I'll go ahead and plug that in. And there you see that point. If I move the it does it all number slider to 0.25, that point we just created almost meets the center point. So now we have our 3 points to make our triangular surface. So that's what's happening in this first part of the definition. So let's go ahead and add some more labels. We can group this last slider point together. Okay, so again, talking about keeping this organized so that when a week from now self comes back and looks at this definition and says, what was my today self thinking of when my today self created this definition? So I can add a couple more scribbles in here just to say what I was doing. So this is make triangle surface. I can make that larger. I can use my control key and I can rotate this. So that's what I'm doing here, make triangle surface. So let's actually make the triangle surface. And I can do that with a 4-point surface. I know we've only defined 3 points, but Grasshopper will make the surface if I plug in 3 points. I don't need all 4. So I can plug in these points. Here's the center point. Here is my lower left point. And here is my slider point. And it creates that triangle surface. Now to complete the rest of the definition, I can mirror this surface, and then I can do a polar array to create the other 3 remaining parts. So let's go ahead and do that. Now to mirror this surface, I can use a mirror capsule, and be careful, there is a mirror surface which does something different than I want. I just need a standard mirror, and what I need to do is I need to define the mirror plane. And what I want to do is I want to define a plane that is perpendicular to this diagonal line. So it's like a slice plane, and we'll see that in a little bit. Okay, so let's create that plane. And I'm going to need 3 points to construct the plane. Let's go ahead and type in plane. And there's a plane 3 point. Okay. Point A is going to be my slider point. So I have that here. Point B can be my center point, the original lower center point. So So I have that here. And then my third point, or point C, can be the raised center point. And I have that as well. See, these labels are working out for me. Okay, so there's my mirror plane. You see that perpendicular to this diagonal line. So when I plug that in, and I plug in the geometry, it's going to mirror that for me. And the It Does It All number slider now is going to control the folding of those two triangles. Okay, so let's just organize this a little bit. So the last thing we did was we mirrored. So mirror. And our mirror capsule was necessary, and also setting up our 3-point plane. So I can group these. Okay, so the next thing that we need to do is we need to make a polar array to get the remaining 3 sides of the folded structure. So bring out a scribble. This will be our polar array. And I'm going to bring out a capsule called polar array. So it's looking for a geometry to array, which is going to be our 2 triangular surfaces, because our mirror creates our second triangular surface. And we have the original one is here. So it's that surface and this surface that we're going to polar array. So let's join those 2 surfaces together. We can use, if I double click and type in join, there's a BREP join. BREP stands for boundary representation. Surface is considered a BREP. It has edges and points, and it makes a surface, so it's a boundary representation. I can plug these 2 in to my BREP join using my shift key, and coming out of the BREP join is 1 open BREP. So I can plug this in to my geometry of the polar array, and you see something crazy happening here. And what's happening is this array by default is the center point of this array, and the plane is the XY plane that is centered on the 0 point. So it's polar arraying about that point, and the count at the moment is set to 10. So we need our array plane, or the center of our array plane, to be our centroid. So let's create an XY plane, which is a flat plane, and let's tell the origin of this plane to be the center. So I can plug in the centroid, and you'll see now that plane showed up here. Okay, I can plug that into my plane input on my polar array, and now we have the polar array happening where it should. It's just that the count is set to 10 by default, so we need a count of 4, and I can plug that in. Okay, so we're getting there. It looks like we're just about there. We just have to organize this a bit. I can group it. change its color. Okay, so let's go back to our it does it all number slider and see if it actually does it all. Now it will error out at 0, so you just have to keep it just above 0. So that's it for part 2 of the folded structure.